Hello, my name is Robin Mitchell, and today Electropages is here in Embedded World Nuremberg. And today I am at the Solid Sand booth, and I'm joined by Marcel.
Thank you.
So, could you just give us a quick brief of what it is that your company does and what services it provides for engineers?
Yeah, our basic product is a test suite for the implementation of C and C++. So that means if you get a software development kit, it has a compiler in there and it has libraries.
Like GCC, that kind of thing.
Yeah, for example, it could be GCC based, could be LLVM based, but also for particular specific processors, there are many compiler implementations that are not based on GCC and LLVM.
So you might test compilers aimed at specific processors. So it could be maybe some new microcontrollers come out, and then your job will be to make sure that the compiler works with that microcontroller.
Yeah. And there are many of these small microcontrollers that have a very long history, and they still have compilers that are updated and modified. And we can deal with those too, those processors as well.
Now, before we started this interview, we talked a bit about things like the standard library. Could you just explain why it's important that standard libraries are sort of standardized and ensure that they work across different devices?
Yeah, now we get into the safety part of it. So we introduced SuperGuard for C, and that is a specific tool for library qualification. So when you want to use the C library, the C standard library, in a safety critical device, and that can be in the automotive industry, but it can also be in the medical industry or in robotics, So there are a lot of safety critical industries, and they have their own safety standards. And for libraries, the safety standard says that you have to verify the library as precise as you would the rest of the application, because the library is going on the processor, so it's linked with the program, with your program that you as a developer write, and it goes into the device. So if you want to do that, you have to make very sure that this library is indeed okay. And so for that there are these functional safety standards, and they describe processes for the qualification of the library. And that means that you have to do a number of steps. One of them is, of course, testing.
Yeah.
But the most important thing of this process is that you show how the specification of the library, how that links all the way to your test and the results of your test. So that is a transparency, that is a kind of traceability of the requirements in the C standards all the way to the test. And you also have to show that the tests are complete. How do you know that they're complete? So for that you can use coverage analysis, so that's one way. But also you go to the standard and derive from the standard what are exactly the requirements that are described there for the library. And then for every requirement, you better make sure that you have a matching test, of course. So these are two sources of where we develop tests and why we develop tests.
And just to be clear, these are the standard libraries for C that we're testing here.
Yeah, and again, there are many implementations of the standard library. So, the GCC implementation is a very well-known one. But there are also, especially in the embedded industry, because if you take a library that was developed for a PC, that library is going to take maybe a lot of resources. While if you're dealing with this tiny processor that controls, there are even processors in the speedometer. So the needle of the speedometer, behind that there's a little processor, and it runs code. And that's a tiny processor. So you can't put a PC quality library.
Of course, yeah.
So there are many variants of standard implementations of the standard library.
And so those libraries will be cut down, but it's important that those libraries are still safe.
Yeah.
And so your job is to go across all those C compilers, across all those different microcontrollers, and making sure that those C standard libraries and the C compiler itself all produce the same result, so that they can all be used in safety applications.
Yeah,
fantastic.
That's correct. And so our test suite is really requirements based.
Yes.
And the requirements are the same for everybody.
Yeah.
And we show then that we can then show with our testing tools that the library implementation indeed is compliant to the requirements.
And those requirements and tests, do they check things like memory pointers, stack sizes, or is that what it looks at, or
Well, resource usage, that is what is known as non-functional requirements. So that doesn't really fall under the functional safety libraries, not when you start from the requirements in the language standards.
yeah,
So by default, we stay away from that because those resource requirements are also not defined in the C library standard. It's a little bit different for C++. So in C++, for example, you can find for certain data structures that it says, okay, this data structure is expected to behave linear or logarithmic. So there are some requirements in the C++ specification, but for C, that is left up to the implementation. Now, fortunately, many of the kind of functions that you find in the C library, they are quite predictable in their complexity. So something like a string length, that's not a quadratic operation string length function. That's obviously a linear function. So there's not so much you need to test and you need to verify there. But in general, we are based our test suite on the requirements that are really in the standard.
Now, I'm looking at some of these posters behind us, and it's on the first one, it lists C++. So it's not just C, but it's C++ that you also check as well. And could you just give us a quick rundown of what this SuperGuard Library Safety Qualification Suite actually is?
Yeah, SuperGuard. So SuperTest is our original oldest product.
Yeah.
And that was aimed at verifying everything. Basically,
how long ago was that?
Oh, the oldest tests in there are from 1984.
Wow, 1984.
Yeah. So that is 5 years before.
And was C becoming embedded at that point?
Well, C's history goes back to 1972.
Yeah.
And then Cunningham and Ritchie published their book, the KNR programming standard. But then it was not yet a standard, as in an ISO standard. And that effort started in the 80s.
Right.
And the company that originally developed SuperTest, which is not us, we bought SuperTest at some point 8 years ago. But the company that originally developed the SuperTest was involved in the standardization process of C. So they knew, okay, this is going to be a standard, and then it's useful to have a test suite for that. So they got involved in that process. And the original first standardized version, that was known as C89. So that was not an ANSI standard. That was an ANSI standard. And 1 year later, in 1990, it was basically the same standard, but wrapped by the ISO. And that's how far back it goes.
And on that topic of ISO, your services would essentially make sure that someone's C compiler is ISO certified.
Yeah, when it comes to qualification, you deal with two standards actually.
Right.
So one standard are the ISO standards for the language, and then we have C90, C99, C11, C18.
And that's the actual text that you write as you program.
Yeah. And we can verify any version of C as well. So the test suite is organized in such a way that you can pick which standard you're based on. But that's the language standard and then the library standard. But the second standard that you need to qualify, that you need for the qualification, is the functional safety standard.
Yeah.
And so
and that's the compiler itself, isn't it?
No. That is the functional safety standard that is required when you develop, for example, software that goes into the brakes of your car.
Like testing functions and stuff and making sure that they.
Yeah, no, it's a bit confusing. It's called functional safety standard because you verify.
To make sure that the code itself operates as it should.
Yeah, the functionality of the device that you implement adheres to the requirements that you have.
Yeah.
And Solid Sense, we grew over the past 8 years in this unique situation that we both have a very good understanding of the C language standard and the C++ language standard, and also these functional safety standards, how to apply these processes that are defined in the functional safety standards to library and compiler qualification.
So just out of curiosity, who would you say are your biggest customers?
We have many actually.
Many customers.
No, it's not just in many different areas. I mean.
Yeah.
So we have, I just mentioned already, we have the Sony PlayStation group.
Oh, yes, of course, yes.
Yeah, and they just want to make sure that the software development kit for the Sony PlayStation is compliant to the C standard.
Yeah.
That's their goal, so just quality.
And in that way, when they have other developers from other games, they can all make sure that their standard libraries are going to work when they use them on this platform.
And they are a supplier of tools.
Yeah.
We also have suppliers of tools like Synopsys, and they want to.
Oh, Synopsys, yes.
Yeah. So it's for the ARC processor.
Oh, yes.
It's a tiny microcontroller, and it's used a lot in USB devices, but also in audio, car audio. And they want to make sure that this their compiler and library can be used in safety critical applications. So they also want to qualify. And then we have a lot of customers that are using compilers. So they're not developing compilers themselves or libraries, but they are users. But the functional safety standards say, well, when you use a library, make sure that it is suitable for your purpose.
And so
they then have to qualify.
And so in that case, let's say I'm an auto manufacturer.
Yeah.
And I build, like you say, the brake system.
Yeah.
I might use someone else's compiler, but I can send my completed project to you to check that it does conform to safety.
Yeah, there are two ways basically, or you can ask us to qualify the compiler in the library. We provide you with a qualification report, and then you can take that to a certification authority, like one of the TÜVs, and then the TÜVs, they go through that report and they compare it to the functional safety standard, and they say, okay, you follow the process correctly, and they put a stamp on it, and that makes it certified.
Ah, brilliant.
What was the second part of the question?
Oh, that's a good question. It was about would you take the code which I've written? The first half was the compiler side. The other half is the code side, I think.
Yeah, we differentiate between compiler and library because the processes for functional safety qualification, they are different.
Yeah.
The library is not going into the car. Sorry, the compiler is not going into.
No, that's right. Yeah.
The library goes. The library is linked into the application, but the compiler not. And for that reason, the compiler qualification process is different from the library qualification process. And that's coming back to your question way back. SuperCard is really aimed at library qualification. It's this quite tough process of qualifying code that goes into the car.
And so this is not testing the compiler, this SuperGuide is testing your libraries that you're using in your safety critical application.
Yeah, the standard C library, and we're now expanding also into the standard C++ library.
Okay, and would SuperGuide also cover custom libraries that a customer may have designed themselves?
Only if it's an implementation of the standard library.
Only if it's an implementation of a standard library.
So if someone has developed a new data structure, maybe a database data structure that is not defined in the C standard, then we do not have tests for that.
And that's because you can't be sure of how it fully works.
Well, first of all, you need good requirements for that. So you need a very good specification of that thing.
Yeah.
And based on that specification, you then to develop your.
And that's why engineers should try and use standard libraries as much as possible.
That is certainly helpful, yes, because in the C world, these standard libraries, they are used by so many people.
Yeah.
Not just safety critical applications, but certainly mission critical applications. That errors in there, they will surface, and so those standard libraries, especially the open source ones, are quite well tested and quite reliable.
So for engineers who are currently watching this podcast and they want to get in contact with Solid Sands to look at your different services, what would you recommend?
Go to our website, so that's solidsense.nl. We're based in the Netherlands, in Amsterdam. And the website has all the information that you need. We have in there, we have quite a lot of white papers as well, so technical documents that people can read to get some background on what we do and why we do it and how we do it. But there's also, of course, product descriptions there, contact information is in there, and that's how you reach it.
Fantastic. Well, thank you ever so much for taking the time to see us today.
Thank you.